first Earth-sized planet orbiting in the habitable zone of a star outside our solar system.
The world's largest and most powerful space telescope, James Webb Telescope,
is to detect the very first stars and galaxies that were born in the very early universe.
For centuries, the moon's far side has remained a hidden mystery.
For all of history, the far side of the moon was invisible to the Earth. It's the back side. You can't see it.
But the James Webb Space Telescope has made a groundbreaking discovery on this side of the moon.
One of the James Webb Space Telescope's main goals is to study quasars in the early universe and reveal their host galaxies for the first time.
A massive, mysterious structure has been detected, hidden from our view for billions of years.
In our modern universe, exploding stars scatter heavy stuff, shaping gas clouds into smaller stars.
What do you think it is? Is this an alien megastructure, a natural wonder beyond our comprehension, or something else entirely? Let's find out. Number 1. Huge structure on the dark side of the moon. Space has forever been humanity's final boundary, but thanks to technological marvels like the James Webb Space Telescope, we're starting to fill in some of those blanks, like our lunar neighbor. The moon as we know it has two sides. The near side, we know a lot about, and the far side, the mysterious one. Contrary to popular belief, the dark side isn't constantly concealed in shadow. It gets its fair share of sunlight, just like the side we see.
The far side of the moon was invisible to the Earth. It's the back side. You can't see it.
But the reason we always see the same side is due to synchronous rotation, where the moon's spin matches its orbit around Earth.
Gravity holds on to it so tightly. The same face points towards us at all times.
Exploring the far side means no walking in the park. Since the moon blocks Earth's radio waves, staying in touch is a real challenge. But that hasn't stopped nations like the US and China from diving headfirst into this lunar mystery. With instruments like the Webb Telescope, we're now able to even find the huge structure on the dark side of the moon. Initial analysis suggests it could be a natural formation, possibly a result of ancient explosive activity or a massive impact event. However, the size and shape of the structure also open up intriguing possibilities, leading some to speculate about artificial origins. So the exact nature and origin of the structure are still under investigation, but it appears to be composed of materials not typically associated with natural lunar formations. The structure exhibits geometric patterns and alignments that suggest it may not be a natural formation, prompting numerous theories about its possible origins. The discovery of this massive structure paves the way for future missions. Both NASA and other space agencies are now more eager than ever to explore the far side. With the Artemis program aiming to return humans to the moon, there is potential for detailed study of this structure. And who knows, maybe there's a surprise waiting around the next lunar crater, or perhaps something truly mind-boggling hiding on the far side. The possibilities are as endless as the universe itself. Number 2, oldest galaxies. The new images from Webb Telescope reveal that the first stars and galaxies might have formed in ways we didn't expect, and the universe could be much older than we thought. There is one galaxy, Jade's GSZ 14D0, which existed just 300 million years after the Big Bang. According to our current understanding of the universe, galaxies like this one shouldn't have formed so early. This means we might need to rethink some of our fundamental assumptions about the universe. Another galaxy, JD's GSC 13D0, a type known as a Lyman break galaxy, shows intense star formation just a few hundred million years after the Big Bang. This type of galaxy is usually found at closer distances, but finding them so early in the universe's history adds to the puzzle. Number 3, first light. In the early universe, The space between galaxies was filled with a fog of neutral hydrogen, making it opaque. However, about 1 billion years after the Big Bang, ultraviolet light ionized this hydrogen, making the universe transparent and allowing light to travel freely.
And so we're designing the James Webb Space Telescope to see past the point where Hubble could see and to see the very first stars and galaxies to light up after the Big Bang.
The source of this ultraviolet light, which created the era of reionization, was a mystery until the EIGER project, led by Simon Lilly from ETH Zurich, used the Webb telescope and ground-based telescopes to study a distant quasar called SDSS J0100 plus 2802. But why in the world would we need to study a quasar, and how is it related to the first light? Well, that is where the light was coming from. And in case you didn't know, a quasar is a supermassive black hole emitting a bright light that can illuminate gas along the line of sight, helping astronomers study the state of the gas around intervening galaxies. Number 4, exoplanet atmospheres. NASA's Webb telescope found water on a planet more than 1,000 light-years away. What else do we know about this planet? This planet, called WASP 96b, is a hot gas giant orbiting a star much like our Sun.
The planet's surface is around 1,000 degrees Fahrenheit because it orbits its star so closely, at just 1/9 the distance between Mercury and the Sun.
James Webb has provided the most detailed look at this exoplanet's atmosphere. So what exactly did it detect? Well, there were clear signs of water vapor in the atmosphere of WASP 96b, a planet with a surface temperature of around 1,000 degrees Fahrenheit. The telescope also found evidence of haze and clouds in the planet's atmosphere, which were not expected to be there. And now, it's time to talk about some nerd stuff about this discovery. Like I said, they found clear signs of water there, so they turned the data from this discovery into sound. Each piece of data makes a different sound. When the planet blocked more light, the sound was louder. Longer light waves made lower sounds, and shorter waves made higher sounds. You can even see a line move across the screen, playing a note for each bit of data. When they found water, it sounded like water droplets. This way, you can actually hear where the water is on the planet. And honestly, this was a pretty huge discovery, even though the planet is too hot to support life as we know it. Number 5, star formation. And then astronomers found a galaxy full of surprises. Astronomers have found NGC 7469, a spiral galaxy located about 220 million light-years away in the Pegasus constellation.
There is a superluminous center area in NGC 7469 called an active galactic nucleus, or AGN, that is illuminated by gas and dust falling into the galaxy's central black hole.
At the heart of NGC 7469, there's an incredibly bright center known as an active galactic nucleus. This brightness comes from gas and dust falling into a central black hole, making it glow brightly. What's really fascinating is that this active galactic nucleus is very close to a ring where new stars are being born, known as a starburst ring, just 1,500 light-years away. This galaxy became famous when the James Webb Space Telescope took a stunning picture of it. Thanks to its advanced infrared technology, astronomers discovered 66 regions where new stars are forming in NGC 7469. Nearly half of these regions were invisible to the Hubble Space Telescope. Most of these star-forming spots are gathered in a ring around the galaxy's core, stretching about 3,200 light-years across. Astronomers have also observed high-speed outflows of ionized gas moving at about 4 million miles per hour, adding even more excitement to this discovery. Number 6, dark matter mapping. We have all been fascinated by dark matter ever since we first heard of it, right? Dark matter is a mysterious substance that makes up about 27% of the universe. Unlike regular matter, dark matter doesn't emit, reflect, or absorb light, making it invisible to our instruments. This means we can't see it directly, but we know it exists because of its gravitational effects on visible matter like stars and galaxies. And how did we discover dark matter? The idea of dark matter started hundreds of years ago with the discovery of dark nebulae, dense clouds that block light.
Scientists can then compare these data to ideas of dark matter's function in their process.
In the 20th century, astronomer Fritz Zwicky noticed that galaxies in the Coma cluster moved in a way that suggested there was more mass than we could see. Later, Vera Rubin found further evidence that galaxies rotate in a way that can only be explained if they contain dark matter. Now, we have the James Webb Space Telescope, which helps scientists study gravitational lensing, which happens when a massive object bends the light from objects behind it. This bending can show us where dark matter is hiding. By capturing these tiny warps in space-time, this telescope is revolutionizing, helping us map dark matter and understand it better. Number 7. Protoplanetary Discs. The mid-infrared instrument on the James Webb Space Telescope is great at looking through dust to study the birthplaces of planets. It can even detect water vapor from icy pebbles. Astronomers used MIRI to observe 4 protoplanetary disks around stars similar to our Sun, located about 370 to 400 light-years away.
The structure and chemistry of protoplanetary disks are determined by many factors.
They found water vapor in all 4 disks, which supports the idea that icy pebbles bring water to forming planets. One interesting find is that smaller, denser disks have more water vapor, making them better at forming water-rich, rocky planets. Larger, thinner disks, which have formed big planets, have less water vapor but might get water from other sources like comets or asteroids. These larger disks could also have more diverse planetary systems due to the influence of their big planets. Number 8. Brown dwarf. And they're brown dwarfs in star clusters. But what exactly are they? Brown dwarfs are kind of like stars, but not quite. They form from gas and dust like stars, but don't get hot enough to shine brightly. They're bigger than planets, but smaller than stars, fitting into a unique category.
The discovery was made as part of the Through the Looking Glass, or GLASS JWST project, a JWST early release science.
Most astronomers agree that brown dwarfs have masses between 13 and 80 times that of Jupiter. The coolest and dimmest among them are called T-dwarfs, with temperatures ranging from 500 to 1,500 Kelvin. The Webb telescope recently spotted some of these brown dwarfs in a star cluster. One of the coolest discoveries is a new, faint, distant, and cold brown dwarf named GLASS JWST BD1, which is about 31 times the size of Jupiter. Number 9. Black hole growth. In the early universe, when stars and galaxies were just beginning to form, huge black holes emerged from the remnants of massive stars or dense clouds of matter. These black holes were so powerful that they could swallow everything around them, including light.
A black hole is so massive and powerful that it can outshine its host galaxy, which is also one of the earliest galaxies ever observed.
A recent study using the Webb telescope has revealed a supermassive black hole that existed just 570 million years after the Big Bang, meaning it's about 13.3 billion light-years away from us. This black hole is incredibly massive, roughly 100 million times the mass of our Sun, and shines so brightly that it outshines its host galaxy. Previously, it was believed that supermassive black holes took billions of years to grow to such sizes. So how did this black hole grow so quickly? Did it start from a massive star, or did it form directly from a giant cloud of gas? These are questions scientists are still trying to answer. Number 10. Molecular clouds. The Webb telescope has also made a discovery in a giant, dark and dusty region of space called a molecular cloud. What are molecular clouds? These clouds are sites in the universe where new stars are born. Last year, scientists even found RNA essential for life in a similar cloud near our galaxy's center. Webb uses infrared light, which is different from what our eyes can see, to look through the dense gas and dust that hide these objects from other telescopes like Hubble. With this infrared vision, Webb has detected the coldest ice ever found in a molecular cloud. Number 11. Galaxy collisions. There are thought to be up to 2 trillion galaxies, many of which have collided with each other over the past 9 billion years. Currently, 2 small dwarf galaxies are merging with the Milky Way, and in about 4.5 billion years, the Milky Way will collide with the Andromeda Galaxy. Since the James Webb Space Telescope started sending back incredible images on July 12, 2022, we've been able to see stunning galactic collisions and mergers of galaxies. Webb's images show the results of such collisions, like the Carina Galaxy's transformation after a collision, and the NGC 2445 and NGC 2444 merger, which created a triangular shape with intense star formation. And that's just the start of what discoveries James Webb has made. Number 12. Stellar death. Stars, those brilliant points of light that dot our night sky, are born, live out their lives, and eventually die. Thanks to the Webb telescope, we've got a closer look at how stars die, showing us details we've never seen before. With its powerful infrared vision, the Webb telescope has observed stars in their final stages of life. These dying stars, called red giants or supergiants, go through dramatic changes. They shed their outer layers, leaving behind a core that might become a white dwarf, neutron star, or even a black hole. One of the most amazing discoveries is how the telescope captured stellar winds, streams of gas, and dust being ejected from these dying stars. The heavy elements created during a star's life are spread into space, where they help form new stars, planets, and even life itself. Number 13. Distant quasars. Like we talked about quasars before, the galaxies with a supermassive black hole at their center. The black hole pools in matter, which gets heated and emits a lot of light and radiation. This makes quasars some of the brightest objects in the universe. Now, the James Webb Space Telescope was built to study these early quasars.
One of the James Webb Space Telescope's main goals is to study quasars in the early universe.
Using its near-infrared camera, it focused on 2 quasars discovered by the Subaru telescope in Hawaii. These quasars, named J2236 and J2255, are 13 billion light-years away. Webb's sharp images captured the starlight from their host galaxies for the first time ever. These galaxies are incredibly massive, with black holes 1.4 billion and 200 million times the mass of our Sun. This discovery hints at a link between the growth of black holes and their galaxies over time. Number 14. Discovery on Mars. Mars has always fascinated us. Elon Musk and his company SpaceX are planning to send humans to Mars within this decade, aiming to eventually settle on the planet. Before this happens, scientists are using James Webb to learn more about Mars from afar.
The rover went over the crater floor and gathered 8 rock samples to keep them from threatening life on Earth.
This advanced telescope, built to observe far-off objects in the universe, recently made an exciting discovery on Mars: organic molecules, the basic ingredients for life. This suggests that Mars might have experienced chemical processes similar to those in batteries, possibly creating these life-building molecules. Number 15. Southern Nebula Ring. The new images from James Webb showed details we had never seen before. It gave us such a clear view of the Southern Ring Nebula, which is 2,000 light-years away. This star orbits closely around its partner, occasionally ejecting layers of gas and dust. These layers form an amazing, uneven pattern of shells around the stars. Webb's near-infrared images also highlight bright spots, where light peeks through holes in the nebula's dusty layers. You might recall that the Southern Ring Nebula was among the first images released by Webb. Back then, Webb spotted two stars. One dying star that created the nebula by shedding its layers, and another star orbiting it. Now, after a closer look at Webb's data, scientists think there might be even more stars hidden in there, possibly up to 5, all contributing to the nebula's unique shape of gas and dust. Number 16. Jupiter Views. NASA's James Webb Space Telescope has also spotted something amazing on Jupiter: a high-speed jet stream in the planet's atmosphere. This jet stream, which is over 3,000 miles wide, zooms around Jupiter's equator at an incredible 320 miles per hour. That's super fast, right? The telescope also snapped some breathtaking images of Jupiter, showing off the famous Great Red Spot and the colorful stripes that wrap around the planet. You can see bright white spots in the pictures, which are high-altitude clouds, and the green and red glow at the poles are Jupiter's auroras. Even after years of studying Jupiter, there's still so much more to uncover about this giant planet. Number 17. Stefans Quintet. A dance of galaxies swirling and colliding in a mesmerizing display of creation and destruction. This is Stefans Quintet. For over a century, this group of 5 galaxies has captivated astronomers and stargazers alike.
5 galaxies, located about 300 million light-years away.
At first glance, they appear as a close-knit family, but looks can be deceiving. 4 of these galaxies are actually near each other and interacting, while the 5th one is just in the same line of sight, but much closer to us. And then there's NGC 7320, the Outsider, a spiral galaxy bursting with new life, with its fiery red regions filled with newborn stars. Number 18. Universe Breaker. A time when stars were just starting to ignite and galaxies were taking their first breaths. This is where our next story begins.
On the previously undetected giant.
The James Webb Telescope made another groundbreaking discovery. It's found 6 galaxies so massive, so ancient, that they're challenging everything we thought we knew about the early universe. These galaxies existed when the universe was just a toddler, only 3% of its current age. They're so big they've been named universe breakers. These galaxies are packed with as many stars as our Milky Way, but they formed billions of years earlier. Number 19. Supermassive black holes. A universe still covered in darkness. A time when the first stars were just beginning to shine. Now picture a monster hiding in the shadows. That's right. Astronomers have discovered a supermassive black hole, a huge cosmic vacuum hiding in the early universe. And it's unlike anything we've ever seen before.
Another idea is that many black holes could band together quickly.
The James Webb Telescope spotted this, and it was incredibly red. Not the kind of red you'd expect. So where did this red come from? The red color comes from the expanding universe stretching the light as it travels to us, indicating that the black hole is surrounded by thick gas and dust. Number 20. Jumbo. The Webb telescope also discovered Jupiter-sized planets floating freely in space, not orbiting any star. What's really interesting is that these objects seem to be moving in pairs, which is puzzling astronomers. The telescope spotted about 40 pairs of these objects in a detailed survey of the Orion Nebula. They've been nicknamed Jupiter Mass Binary Objects, or JUMBOs.
These so-called Jupiter-sized mass binary objects, or JUMBOs.
One idea is that these objects formed in areas where there wasn't enough material to create stars. Another possibility is that they formed around stars but got kicked out into space. Right now, the kicked out idea is the favorite, but scientists are still trying to figure out how pairs could get ejected together. Which idea do you think is more plausible? Professor Mark Makarian, who led the survey team, said, "It's hard to explain how objects as big as Jupiter could form on their own, and we know single planets can get kicked out of star systems." Number 21. Planet of Diamonds. And the next discovery is a planet made of diamonds. You heard that right. The planet is called 55 Cancri. About 1/3 of its mass is made up of high-pressure carbon, which we believe is in the form of diamonds. Think the Earth is hoarding all the diamonds? Guess again. The total diamond hoard on 55 Cancri E is worth an unbelievable $26.9 non-illion. To put that in perspective, that's 26.9 followed by 30 zeros. That's an unimaginable amount of money. And of course, us greedy humans would already have tried to make this into another industry. Number 22, Lava Planet. Now, what if you were living on a lava planet that's constantly battered by horrible weather? These planets, known as lava planets, orbit very close to their stars, making them incredibly hot. Much hotter than planets like Mercury or Venus in our solar system. One such lava planet is K2141b, discovered in 2018. K2141b is a super-Earth with a mass nearly 5 times that of our planet and a radius about 1.5 times larger. This planet orbits around its star incredibly fast, completing one orbit in just 6.7 hours. This makes it one of the fastest orbiting exoplanets we know of. But what makes it fascinating is its extreme conditions. Number 23, Liquid Water Life. Kepler 186f. It's the most Earth-like world we've found so far, raising hopes that we might not be alone in the universe. Most planets we've discovered are too close to their stars to support life, but Kepler 186f is different. It's just the right distance from its star, which means it could have water and maybe even life. This planet is the first one similar in size to Earth found in a habitable zone around another star. NASA's Kepler Space Telescope spotted it using the transit method, along with 4 other planets that are slightly bigger and orbit closer to the same star. Number 24, Martian Methane Cycle. Scientists also found methane on Mars, and it got everyone buzzing. Why is methane such a big deal? Well, on Earth, most methane comes from living things. So, finding it on Mars is like discovering a potential clue to alien life. But hold on, there's a twist. Methane can also be produced by non-living processes. So, is the methane on Mars a sign of little green Martians, or just a planet with an active geology? Scientists have been chasing this Martian methane mystery for years. But here's the thing. The amount of methane seems to change over time. Sometimes it's there, sometimes it's not. What's going on? No one knows for sure. Number 25, Organic Compounds. NASA scientists have also uncovered organic salts on Mars. These salty compounds are like tiny time capsules, holding clues to Mars's past. But wait, what are organic salts? Well, these salts are basically the leftovers of organic compounds. So, finding them on Mars is like discovering a piece of a giant puzzle. But these salts could have been created through natural processes, like those happening deep within the planet. This is where it gets really interesting. They could be leftovers from ancient microbes that once called Mars home. And that was it for today. Hope you enjoyed the video. What do you think about these latest findings by the James Webb Telescope? What's your favorite space discovery so far? If you enjoyed the video, make sure to like, share, and subscribe to the channel. Also, don't forget to hit the bell icon to get all our videos on time. Until next time.